In this video, we'll demonstrate PowerFactory's techno-economical calculation function. This analysis is an economic assessment of proposed network expansion projects. The investment costs of a particular strategy are compared with the financial benefits that come from reductions in costs associated with system losses and expected interruptions. These quantities are determined during the techno-economical analysis using a load flow or quasi-dynamic simulation in conjunction with reliability assessment. Study case 06 in the MV distribution network project should be activated. Let's look at this part of the network. Two possible options for strengthening the network have been designed, and each has been created in a separate network variation. When assessing a network development strategy, the concept of NPV or net present value is used. NPV captures the total value of an investment over a period of time by netting off incomings and outgoings with the option to take into account an annual effective discount rate. Let's see what this means in PowerFactory. In the variation expansion stage, where a development is modeled, there's an economical data page. This tells us the initial expenditure and the ongoing costs for the new equipment. The new equipment has some value which depreciates over time, so its value 4 years after installation, for example, can be calculated. The techno-economical calculation uses this information together with a reliability assessment to calculate NPV over a given time period. The total NPV is calculated as shown here, and a lower NPV is generally favorable. Let's now run the calculation for the first option. This study case needs to be activated. In this study case, the variation expansion option 1 is activated, and we can see the new line that's created. The command is found in the Economic Analysis Tools toolbox. A study period of 6 years has been set up, and the calculation points defined. These are the points in time for which cash flows are assessed, and load flow calculations are used to evaluate system losses. On the Costs page, costs for losses are defined. There are options to consider interruption costs using the reliability assessment command and to reconfigure the relevant tie open points in order to minimize costs using the tie open point optimization command. The calculation is executed. This icon is used to run a report. Here we see the investment at the beginning of 2026. From that point onwards, there are ongoing costs for the new equipment. The costs of network losses are calculated together with expected interruption costs. Offset against these costs is the depreciated value of the new asset, and this gives the NPV. But is this a good investment? One way to look at this is to run an efficiency calculation which calculates the benefits in terms of reduced losses, costs, and interruption costs as a percentage of the investment. This can be done via an inbuilt script. The results are seen in the output window, and the positive efficiency ratio figures indicate that the network expansion would be beneficial. Let's now activate the next study case. This looks at option 2, where a different line is added. This line is a bit more expensive to build and has higher ongoing costs. The techno-economical calculation can be repeated for this option, and it's then possible to compare the two sets of results manually. However, there's another inbuilt script which can be used to automate this comparison process. We'll go back to the initial study case where the relevant script command has already been prepared. The two study cases representing the options are selected here. Both will be compared with the do-nothing case, which acts as a reference in order to see the advantages and disadvantages of each. At the end of the assessment, a report is generated so that the two cases can be easily compared, for example, the net present value. Additional quantities can be added as required. And these plots are a good way of seeing how the two options compare. As a reminder, Option 2 has somewhat higher installation costs than Option 1. Option 1 is more beneficial in terms of reducing losses, whereas Option 2 is more effective at reducing expected interruption costs. Looking at the MPV figures, we see that either option should be worth implementing, with Option 2, the more expensive line, being a marginally better investment.